Hey guys, welcome back. So we are back to our B-9 Lost in Space robot build. It's been a while, but I've been waiting for some custom parts to come in from machine shops and things like that. It takes a long time. The tread section, which is what we're going to be talking about next, is a 2-year process to actually get these treads. So they got here probably end of December, and now finally we're ready to start our build, and this summer is going to be a big push to get the robot going. So it's been a long time since I've been doing a video, since I did the head section here, so we're going to be really digging into this summer. So I hope you enjoy this video series, and yeah, let's get started. We're going to start at the bottom with the tread sections and start working our way up the robot. So let's get started. So we're going to start with the tread section now, and really what's happened here is these are custom made tread sections out of steel, and these are laser cut sections right here. So this took quite a long time. This was a 2-year process to finally get these, but basically you know, let's take a look at them. Tread sections work is they have these slots in the front here for 2 sets of wheels. So there's wider wheels here and thinner wheels here. So the 2 treads that you saw on the robot in the TV series, you know, are different width treads. And there's 32 wheels between the 2 halves and the 2 sets. So you can see there's already pre-drilled holes everywhere for the shafts of the wheels. And then there's different slots for different purposes here. So this slot right here is for idler wheel to put tension on the belt, and a couple other things. And then they come in these 2 halves right here, and these 2 halves will be joined together with a spacer in between to leave just the right amount of space between the 2 sections. So they kind of like go together, like sort of like this, you know, a lot closer obviously. And then on the front here, there's this door, which you can see right here, sort of opens up. And this is for the soil sampler, which we'll talk about later. But this was something that was in just a couple of episodes, maybe 2, 3 tops in the series, where the robot had a soil sampler that sort of came out, dug into the ground, took a soil sampler, and then went back into the robot. And so that's what this little door here is for on that one. Now on the back of the tread section, there's a cutout here for the power switch and the cord when you're plugging it into the wall for either power or charging it up, charging the batteries up. So, and then on the top here, there's some, you can see it's quite, you know, there's quite a lot to it here. There's a panel inside here that's inside the outer panel that's welded in here also. So this was you know, quite a big job. These are all laser cut here, and then all this welding, and it's really nice job they did on these. And then there's the knee plates right here which get mounted to here, and then there's a knee joint that sort of like swivels right there, and then from there it goes up to the legs. Okay, so that's the main thing. So what we want to do here is we want to mount inside here some motors, because we want to make it mobile. And the way we're going to do that is with you saw on my concept board in my like one of the first videos I did on this, that we're going to use motors, and then motor drivers, and then an Xbox controller to control everything. So what we need to do is get the motors mounted inside here, and what we're going to use are wheelchair motors. So we're going to use these wheelchair motors that you see right here. So these are actually wheelchair motors off of Jazzy wheelchairs. These are going to be the right size that we're going to need. We're going to mount them at an angle, but basically we've got a couple things we have to do to the motor first. So I got these off eBay. They're used. There's lots of sellers on eBay that all they do is sell used wheelchair parts, and so you can get some ones that are, you know, fairly inexpensive. It was like $200 for the pair. But if you were to buy brand new wheelchair motors, you know, they'd be 6, 7, 8. So it's, you know, you got to try to save as much money as you can. But all we're looking for are wheelchair motors that work and don't leak. That's the main thing. But this will be where tire goes on here. And then I'll show you the right size tire we're going to use, because there is a very limited amount of space inside the tread section, so you can't get a giant tire. You have to get a certain size tire. And then we're going to get a mounting plate to mount this inside there. But a couple things to note. So first of all wheelchair motors usually come with some kind of a mechanical brake, which you see right here, which basically when you turn this either engages or disengages the gearing, so that if I wanted to, I could reach into the tread section and disengage it and just roll the robot manually, right? It just lets the wheels roll freely, or engage it and then it's engaged with the motor and you can't move the robot, right, by pushing it. So that we are going to leave on here so that we could reach in from the side if needed to disengage or engage. And I'll show you how we're going to access that, but that's something we'd leave on there. So now some of them come with big long shafts you'd have to get rid of or cut down or do something with, depending which model you get. But like I said, if you get the Jazzy 3 motors, then they are kind of the right size. Now the other thing wheelchair motors always come with is, as you can see here, if I take this rubber band off, we've got a connector here, but the connector has 4 connections on it, and we only want to use 2. And so the reason it has 4 connections on it is because all wheelchair motors, for the most part, you can see here we've got 2 whites, so red and a black, right? All wheelchair motors, for the most part, have an electric brake on them. So it's a brake that automatically engages when there's no power, and you have to have power to disengage the brake. And so 2 of these wires here are for the actual motor itself, just to make the motor power. And then 2 are actually for the electric brake, okay? Well, we're not going to need the 2 for the electric brake, and the length of this is a little bit too long, so we're going to we want to make this a little bit shorter so it fits inside our case. So one thing we have to do is, the electric brake is right underneath this cap here. So basically from this point here to this point here, underneath here is an electric brake, and we need to remove all that so that the only thing we have is a little shaft sticking out there, and that's it. So the motor can basically be turned on and off freely with just the 2 connections. Now these are 24 volt motors, okay? However, our bus system in the robot is only going to be 12 volts, but that's okay, because 24 volt motors will run on 12 volts. They just run slower, and actually that's what we want, because if I was going to run this at 24 volts, the robot would be way too fast and pretty dangerous actually, because you're going to have a couple 100 pounds coming towards you at a very good clip, and we don't want that. We want a fairly slow speed anyway. So we're going to have 12 volts going into these, and that's going to be perfect. That will slow these down. I still be able to do 4 different speeds, but it will slow these way down, and they will work perfectly fine with 12 volts going into them. So even though they're a 24 volt item, you can do 12 volts into them. That works just fine. These I got because they were pretty much sealed and there was no leaks on them, and that's the main thing. Like a lot of wheelchair motors, there's 2 seals on the ends here. You want to make sure they're not leaking. The top cap that goes on the top here, it holds the grease inside here, is not leaking, and then of course the 2 seals on the other side are not leaking, especially the one where the shaft comes out of. Like that's your key when you're looking at used motors. So if you get one from eBay and it's leaking or something, you want to get an exchange or getting a return for it, because that's going to be a problem if it's just leaking all the time down, and then it's going to leak all over your floor, wherever your robot is sitting and stuff like that. So, but anyway, that's what we need to do first. So we need to take this off and then remove all this braking system. We're going to end up with 2 wires in the end, and that's going to go to our motor controller. So I have a pair of these, and they come in left and right. So obviously what will happen is when the bracket's on, this will be sticking out one direction, on the other side it will be the other direction. Now the wheels, when we mount them, they're going to be sort of in the back of the tread section, and then the front will need a set of wheels, sort of like casters or some kind of pivot wheel, so that it can turn. Because what will happen is the motor controller will take the wheels that are on here and either spin them in the same direction at different speeds or spin them in opposite directions, right, to make it turn and things like that. And that's how it'll turn, and it'll really just be exactly like a wheelchair is and be controlled that way. So that's what we need to do next. So before we can get these mounted in the treads, we got to get rid of this electric brake. First thing we need to do is get this cap off the end here, which is just a couple of screws. Should come right off, and we're not going to save any screws or anything. There's just two of them and they just come right off here. And then we just got to get this cap off, which is not going to be easy, right? It's going to want to sort of stay on, so you're going to need to tap it off probably with a little screwdriver and stuff like that. Once you get the cap off right here, you're going to see the electric brake right here. So it's a couple of pieces, but because it's a big magnet basically, so you've got these two wires right here that you're just going to snip off because we're not going to use these anymore. These two white wires just come up through here and then come up to the connector here. So those are just kind of a dead piece we don't need anymore, and those are just going to be snipped off. So you can snip off like basically the right before the cap right here. Just going to snip them off, don't need them. And that's going to take that off right here. Now, this is a whole bunch of Allen screws in here, so you got to get all this off first, and all this comes off. This whole thing will come off, and then you'll end up with just a little shaft sticking out the end there. So let me get an Allen screw and get all this stuff off of here. So this 3 Allen screws, this plate comes off the front here. There's a disc, sort of this, it's kind of like a brake disc in between here where when it pulls it down, it's like the magnet pulls it down and everything. And then you're going to have this, which is attached to the main shaft. So this has to come off first, and then you have 2 Allen screws, and this whole assembly then should pop off. All right, just be careful because there is a spring under here. So this, when you take off that sort of nut on the front of the shaft here, and you got to pry it off a little bit, but it's going to want to fly off, so just be careful because it is under spring tension right here. And so now you can see there's the magnet here and everything, so we just need to take these 2 off, and this whole piece should slide off here. All right, and that's it. There's the big sort of magnet and everything that holds it all together, and that's it. You end up with this. So obviously we've shrunk this down, like this whole thickness right here is now, it's shorter. And what you can do is you have this shaft sticking out here, which you don't really need or have to do anything with, right? But what you can do is if you wanted to get a grinder and then cut this shaft off, right? Now what you want to do first before you do that is put tape all around this and seal this off here so you don't get shavings into the inside of the shaft here, because that's going to be a problem if you do that and then you damage the seals that are inside there. Okay, but if I turn this, you can see in the back here, this is just turning a little bit at a time, right, because it's geared down. And then if I switch my brake here, now nothing's happening. If I turn it, I'm turning it now, nothing's happening there, and this is actually all free, right? I can actually turn this right now. So you have, now it's locked. So you have some nice choices here, because if for some reason the robot is dead, the power batteries are dead or whatever, and you need to move him, you can still push him on his wheels by just disengaging it. So that's the nice piece about using wheelchair motors as opposed to any other type of motor inside the tread section. And for this, you know, we do want to protect the wires, so we'll probably keep this big connector going out right here, but we don't need this, like we'll cut this off right here. We don't need the white wires, we just need the red and the black here for our motor power, and that's pretty much it. And then that's it. So these are, you know, ready to go once I'll cut off this shaft right here. I don't necessarily have to. I'm gonna put them in the tread sections and see if the shaft is, you know, clearing or if it's bumping into something. So like I said, it's a very tight squeeze in there, and we have a lot of stuff to squeeze in the tread section, so it's not just a motor. That soil sampler I was talking about, it's got to squeeze on the one tread. So we've got, you know, very tight tolerances to worry about to get a big motor like this in here. But this will drive it because if you think about it, it's going to be a couple 100 pounds in the end when it's all said and done. So it needs to have enough torque to be able to do that. And obviously wheelchairs, you know, carry around, you know, people that are a couple 100 pounds. So it's, you know, these are up to the task basically. And then you can power them, you know, with as much juice as you want to with the motor controllers. And then, yeah, that should work out. So we got to get the other one finished here. And then the next step after that is to get a mounting bracket on the top here and then start getting them mounted into the tread section itself. So that's our next step. So let me get these two motors prepared and we'll come back. Got our wheelchair motors ready, right? I just snipped off the two little white wires coming out here because remember, they just go up here up to these two up here, so they're not connected to anything, so it doesn't matter. And I don't want stuff sticking out here that's going to hang on, you know, get caught on things or anything like that as the shaft is spinning around. And then, you know, we'll trim that back, this sheathing right here, and we'll then make a connector for the red and the white for the motor itself. So that's that portion of it. So what's next? So the next piece is we need to make a bracket that's going to mount these to the tread section. Now, inside the tread section, there's a vertical wall that these are going to mount to. And what I like about the Jazzy motors is that they have this sort of 6 screws right here that hold on, that you can put a mounting plate on top of here, a 90-degree angle steel plate, and then you'd be able to mount these directly to the side of the tread section, which makes it a lot easier than trying to have to sort of like manufacture a bracket that goes straight across that these are hanging from, right? So you'd have to create a bracket that was sort of straight across and then had probably like either up or down 90-degree angles that were bolted to two sides of the tread section. Well, it's not really necessary. First of all, if you use a angle bracket here that's steel, but it has to be steel. You can't use thin metal or aluminum or anything like that. It's going to bend. So these have to be able to support the entire robot. So you're going to use angle brackets that are steel and drill holes in it. And then once we drill a hole in it, we'll mount it on top of here. And then the angled bracket will have holes on the side of it that will go into the side of the tread section. So basically, when you look at the tread section from one of the sides, you can see, actually, let me take the camera off. We'll go look at it closer. So if you look inside the tread section, we have these, there's like an inner wall right here, right? But then there's this outer wall right here. And this is the wall that we're going to add it to or attach it to right here. And this wall is on the inside, right? So these two come together here like this with a spacer in between. So you won't see any of the bolts or anything that are attaching the motors to the tread section, right? So that's where we're gonna put it in. And what's going to happen is that big motor section is going to squeeze into this cutout that you see right here and go right sort of up against that wall there on each side. And we're going to angle it because we need the space for this front part here. So where we have that little door I showed you before, there's a unit that goes in here for the soil sampler, which is one of the coolest features that will be on the robot, and very, very hard. Most robots don't have a soil sampler, so that unit is a custom-made unit. Next step is to mount a bracket so we can mount this inside the tread section. So we're going to use this piece of 1/8 inch steel. This is a bracket. This is just an L bracket. These are sort of strong ties that they use in construction and everything. Just picked this up at Lowe's. Very easy to find. But what we've done here is we've marked everything out where the locations are of the mounting holes on the motor. So when these are mounted inside a wheelchair, it just uses these 3 mounting points right here. These 6 outside here are just to keep the cap on with the gasket around it for the grease that's in here and stuff. But the only 3 that are actually used are these 3 right here, which is the same thing that we're going to do. But what we have to do is we had to cut some holes in the bracket first of all, for the locations of these particular screws. So that's the first thing you got to measure out and make sure you drill them in there. And then the other thing is you've got to open up 2 holes for this little protrusion that sticks out of the top plate here, and also for the lock, right? So that you can either lock the motor into the gearing or make it freewheel, depending which way you want to do it. So you're going to have to get this all measured. This is this part is tedious. It's the hardest part, making sure all your holes are completely measured accurately. And then all you're going to do then is put this bracket on top here. So if I put this over here, just to get this on here, and let me get this by these little set screws. You can see right here, there are my holes, 1, 2, 3, and we're going to use the original bolts that came with it. These are Allen's, but of course we're going to add some washers and lock washers. It's super important that you put lock washers on here. This is a major motor that's going to be pushing a couple 100 pounds of weight. These can't move around once they're in there. Okay, and I would also recommend maybe a little blue Loctite or red Loctite on side the holes here, so that you can make sure these will never back out or move on you. And that's what you want to do. So that's our next step. We just have to get these brackets mounted on here, and then we're ready to actually then try to fit these into the tread section. So let me get these all mounted on and we'll come back. Now we have this bracket mounted on here, and we've got a bunch of holes here that we're going to mount this to the side of the tread section. And then now the way this is going to work when we put it into the tread section, you're not going to be able to get the wheel on to this shaft right here. It's got a spline on it because there's not enough room once the motor's mounted. So you kind of have to put it in the tread section at an angle, get the wheel on there. It's really tough and tight, but you will get the wheel slid on. And you don't have to tighten it up right away. You can just get the wheel on so it's on the spline and everything. And then you're going to bolt the motor to the tread section. Now, what you're going to need to do first, obviously, is get this lined up without the wheel on the tread section, so you can get your holes lined up here. And then what you're going to have to do is get the wheel on, and you're going to have to basically pick a height. So the wheel has to be obviously below the tread section so it can drive it and the tread section's not dragging along. And you also have to take into account the treads themselves, the rubber treads. So that thickness, and then the thickness of the wheels and everything. And you have to be, maybe I suggest at least a ½ inch below that, so that the treads are basically riding just above the floor when it's riding along. And that's the hardest part that you're going to have to figure out. So I've already got that figured out, but when you do it yourselves, you're going to have to basically play with it, do a lot of measuring, and get a lot of straight edges so that you can make sure that it's exactly the amount of depth below, or sticking out I should say, below the bottom of the tread, so that you're going to have some clearance on the bottom. And that's pretty much all you have to do. And then you'll bolt these on. Now, you can, once you get like one in, then you can twist it and angle it and then drill other holes to get it in there. So the way it's going to look is this. Inside the tread section against that wall there is where you're going to drill some holes and get it in. And you're going to probably have to play with it. And you may drill some holes that aren't going to work, and that's fine because you have plenty of meat on the bracket to drill other holes once you get it mounted where you want. So you really just get one bolt that sort of puts it in its place, get a nice tight lock washer on it, and get it in place. And then once it's in place, you can drill or mark for other holes and then drill through. And you're probably going to want at least 4 holes that you want to go through there. Alright, so you can see on this half of the tread section right here, what I've done is I got it at an angle right here, and here is the shaft, and then the wheel would be on here, which is going to come out below the tread section, right? So if you think about it, zoom out right here, but I just temporarily have the wheels and things on here, but basically the wheel's going to come out below here on the bottom. And so that's one of the reasons. But what I had to do is actually on the tread section itself, I don't know if you can see if I zoom in here, but I had to cut out, as you can see, some of the metal there because I needed to have that lower edge of the motor right there. And it's very close to the wheel, but that's okay. It's not going to touch the wheel, but you know, you have to adjust these types of things. Now, on this side, I didn't have to cut the shaft off because there's plenty of room here. But why am I putting it at an angle here? Why don't I just put it straight like this or something right in here and put it up against here or something, you know, whatever it may be. And the reason is because on the other tread section, we need to have space in the front here for this mechanism that's going to be the soil sampler. So, and the two motors have to be at the same geometry. You can't have one motor kind of mounted one way and the other one mounted another way and the other thing. So they need to be both identical on both sides as far as their geometry. And so mounting it at an angle like this fits perfectly, and then the rubber wheel will actually go down below the tread section right here. It will be sticking out just enough to raise it off the ground, and then we'd be ready to go. So my next step is to get these two motors mounted inside here with the wheels. Now the wheels are these here, which are these wheels right here. And if you want to reference these are 3.0-4s, which it's a weird numbering system that they use for wheelchair wheels, but these are basically, I think, let me measure real quick, but around 10 inches in diameter. So the whole wheel outside diameter is 10 inches on these, okay? And then they have a splined shaft right here, and then the bolt that will bolt it down here. Now these that I'm using here are called Duro Traps. They're like a sort of a polyurethane type of wheel, which I wanted, and they do not have a inner tube in them like a bicycle tire. Some wheelchair motors have inner tubes. This has solid polyurethane filling inside of it, so these never go flat or anything like that, and these will last a lifetime. These will never wear out because it's not like I'm using it for an actual wheelchair and it's on the road or anything like that. But this will be mounted on there, and then we'll get this going. So first we need to get the motor inside here with the wheel on it, and it's a little, like I said, a jog to get it in there, and then we'll bolt up the motors onto the tread section. So we've got the motor mounted right here. So basically there's 3 bolts right here that I, played with until I got them in the right position. And then you can see the motor right here, which is down below right here, and it's sticking down below the main wheels right here. So that's kind of the main position we want to put it in for now. What we have to do is bolt the two sides together first and then see if everything is level, one. And then we have to deal with the front wheel. Now right now we just have a metal wheel on there, which we're going to replace with a nylon one because we don't want to use solid steel wheels on the front there. It'll just tear up any floor it's on. But we just want to level this out and see what we get. And then what has to happen is we got to take it, basically the motor stays in, but all the wheels come off, and then we have to get a good coat of paint on here in preparation for putting it all back together. But before we do any of that, all the drilling has to be done. We got to get everything bolted up and make sure everything's where we want it. Then we'll come back. So we have sort of a base coat on it right now, but the base coat's getting scuffed and scratched and stuff, and that's okay. It was meant to. It was just meant to get on the inner parts so that we don't have to take the motors out when we're ready for the final finishing. We still have a lot of work to do. We've got the back switch and plug outlet that has to go in there. We got the soil sampler. So there's a lot of like still work to do before we're ready to start the paint. But having the motors in here is a big step. Now, the next thing we're going to do is join these two halves together. And the way this works on the halves here is there are basically these 4 posts that stick out from the one side and matching holes on the other half of the tread that will slide onto here, and there's a 1/2 inch spacer, aluminum spacer, that's right here. And that keeps the exact distance between the two tread sections for the correct spacing. And then, obviously any of the bolts head sticking out here then won't rub against each other. Now, the thing about it is we're gonna have to put this together to make sure everything is level, lines up and everything, and then we're gonna have to take it apart again because the wheels here these aluminum wheels have to come off before we do our final paint, because I don't want paint on the aluminum wheels, obviously. So the only way to get these off is from this side with the bolts coming out here. So it's quite a process, right? Because everything has to go in order when you're doing everything. But our next step is to bolt these two halves together and see how close we are as far as level goes and things like that. So here from the bottom, you can see kind of what it looks like. So I've got the two halves bolted together right now, and they're really even with each other. Everything looks good. And if I come down here, you can see the two main drive wheels. That is the rear of the tread section. This is the front up here up top. So you can see I've got temporarily right now two metal wheels. They're on casters, you know, that won't move around. So we're going to change that out with some nylon ones. And right now, you know, I have a level, you know, right here. And what I'm doing is making sure that on the top, it's level both directions. And right now, this side right here is a little low. But luckily, these brackets that I've created right here, I could move them either up and down a little bit or even shim. That's probably the better way to do it, because these are bolted right in the same holes as the wheels. So I just put the brackets right in the same holes as the wheels right there. But what this will do is, if I shim this wheel, this plate right here, so I'll just get another sort of plate underneath it and pull it down a little bit, then I can adjust the level of the treads on the front, and everything then should level out. So right now, this side right here is a little low side. So next we're going to get the nylon wheels and then get those mounted. And this will kind of be our final adjustment here that we need to do to get those on there and mounted. Then what we'll do is get some power to these and just see what happens. So we've got our casters on here now, and they are going to be adjustable. I did level it, and it's fairly level. It's almost perfect, but not quite. This side here is a little bit high up in the robot, so it has to come down just a little bit to even this out. Now we have a little bit of play here on the two bolts that hold the bracket on, but we can always just shim this plate behind the caster here, and then it'll bring it down a little more. So that'll be sort of the final adjustments once we get to the point of final assembly of this area. But right now, our next goal is to get the soil sampler mounted in here and make sure we got all that clearance, because that's the other big piece in here. And once that's in here, then we're kind of set. So I'll show you that piece and how that works. All right, so our next step is to assemble the soil sampler. This is all, you know, custom made pieces. And really all it is we're taking two sheets of aluminum here, which have been laser cut with these slots and everything. And we're just mounting them together with some of these spacers, which have threaded ends in them, and some screws to hold the two halves together, and then some motors that you see here. This is a 12-volt DC motor right here, and there's one also here on the end of this unit, which is already pre-assembled. I've got pre-assembled here, and all it is really just a piece of aluminum here that's been cut in this shape to hold the motor on the end. So it just has two screws holding the motor in the end. And then it has this aluminum piece right here, which is supposed to replicate a drill bit. So this was just a custom-made aluminum piece out of a tube of aluminum with some, you know, ends chopped off to make it look like a drill bit. It just has a set screw right here on the end of the shaft, simple as that. And then on the side here are two shafts or screws that go through with some nylon bushings on them. And you'll see why we're using those in a second. And then we've got some plastic washers right here. And then on the back here, it's just a lever, and that lever is attached to this screw that goes through here. It's just right in the middle there. And a big spring, just a spring around it to make it spring back and forth. You'll see why we need this to spring back and forth in a little bit. But the lever, this again, another piece of aluminum, has a little notch in it right here, and you'll see what we do with that in a second. And then there's 2 micro switches that will be mounted to the side of the plate here, which I already have mounted, as you can see right here. There's one there and one there. So, and if you're not familiar with the soil sampler is, you'll see it when we get finished with it here, okay? So our next step is to get this motor mounted, and it's going to go on. Now originally I had it mounted over on this side, and then I realized that because the wheelchair motor is going to be in the way, I've got to flip it over to the other side, which means because I already have this wired up, I'm going to have to reverse the polarity on it. So the plug that goes into the end of here, because I already have these wired, I had a hot and a ground here already. I'm just going to have to make sure when I wire these up, I reverse them around. So we'll explain that later. But basically, it's just a motor here that's going to be triggered by the switches here. So when we get to the operation, I'll explain it. But for right now, what we need to do is I had to basically, this wasn't planned. So originally I had the holes here drilled on this one for the motor mount. But now, because I have to move it to their side, I had to switch it over to this side. So what I did is I took my 2 plates, put them over each other, put screws in them so everything lined up, and then marked it, and I re-drilled holes on this side. So these weren't drilled by the machine shop like my other ones, which are super clean. These were drilled by me. So that's why the hole looks a little bit not quite as perfect as the machine shop, but it should work. So hopefully everything will still be okay. So the motor here can only go one way because it's got offset holes, mounting holes right here. So it's going to go inside here, and if it fits, if it doesn't fit, we might have to, yeah, I think it's going to need a little bit more actually. I'm going to have to drill it out a little bit more. Not quite there, so I just need to make this hole a little bit bigger. Now these 3 holes I did make sure are exact, so they are in exact same position. So if I make this a little bigger, it should be okay because it's not going to hurt anything. The one in the machine shop is perfect, and this sleeve right here fits right into it, but this I'll have to make just a little bit bigger so this will fit on, because it doesn't look like it's going to fit. Yeah, it's really tight, so just have to run the drill bit through there a little bit more. So let me do that quick. Now that we got the motor on the other side here, the way this assembles is this unit here goes on the inside and into these slots right here. It's a little tricky to get them in. You got to get the nuts lined up exactly. Okay, and that just sort of goes like this, right? And so what happens is this slides down this shaft here as it goes through its process. And then we'll, lube all these up and everything, okay? But now that we have this on the opposite side, we can put this side on and basically put the little posts back that hold everything together here. So let's put one of these posts here, and we'll just hand tighten some screws on these. And this is all stuff you can get at like different online stores that sell all these machine parts, right, for robotics and stuff like that, and all kinds of stuff. Like you can get all kinds of pieces and stuff like that. Really easy to find. The aluminum you'll have to have laser cut, but other than that, and that's pretty much it. Right, so I'll put all the other ones in here. These 2 plates are mounting plates, and they would go down here, the 2 bottom ones, and then that will hold everything together. And then I'll show you how you do the rest of it. I think I got it pretty close to where I want it, but you can see back here where this lever is right here. Do you see how these are not even with each other to start with? So what we want to do is disconnect this, move the motor a little bit down by itself, and then go ahead and reconnect it. Because what happens is when you trigger this, there's two wires that you're going to trigger, and what all these wires do is turn the motor on, plain and simple. But what it's trying to do is get this, once this lever starts pushing this whole unit down this slot right here, it is trying to get past this switch, because when this switch is engaged, it kills the power to the motor. So this is a bypass, basically these two wires, to bypass this switch and allow the motor to operate. And then once the unit starts moving away and this switch opens up here, now it can continue on by itself and you don't need these two connected anymore, the trigger wires. But we don't want to have to wait too long. So for right now, if I try it, what you'll see is, do it like here. I don't know. Hold on, let me get the camera on the other side here so it's a better angle. But basically, because you got to see how the switches kind of work on this. But basically, when I put these two wires together, it starts the motor up, and you'll see the lever right here will start spinning around, right? Because the motor wants to spin around. And it's just a fulcrum bait that basically pushes it. So, but what has to happen is this little micro switch that you're seeing right here has to release, and then it'll take care of itself. So, for instance, if I just touch the wires here, you'll see the motor move. I'm gonna just touch them here. But if I let go, it stops, right? And that's because this switch here is still engaged. But once I get past that switch and it releases it, now you see, even though the wires are apart, it keeps going on its cycle. When it hits the bottom switch, it's going to engage the motor for the drill. And then when it comes back up, it'll stop the drill as it's going back up and then comes around again. So it's just sort of it's kind of a simple design if you think about it. But the motor's just sort of going around here and pushing this down and then pulling it back up. And that's all it's kind of doing here. Okay, this needs to be lubed, right, so it's a little smoother and stuff. But what we want to do, remember, this is going to be controlled by the software that we're going to program eventually. And so we don't want, we basically just want to have a quick tap and it's on its way and it'll do it by itself. We don't want to have to hold it for so many seconds, because otherwise we're going to have to program that in for the program to give it power for, whatever seconds. So if we move this here, so in other words, what we're going to do is we're going to disconnect this here, and we're going to just run the motor by itself, so this moves down a little further. So it's very close, basically, so it's really close to starting the process of pushing this down. And then it will only take a second for this to release instead of 3 seconds, 5 seconds, whatever it may be. So let me get this disconnected here, and we'll do that and just move it a little bit. So if we take this apart right here, where's my little wrench? Now the lever that's attached to the motor has a set screw in it on a flat that is on the shaft. So the shaft has a flat spot on it that the set screw sets against. But this right here, what we want to do is take this out temporarily, just for a little bit, because we want this down here, so when it starts pushing, yeah. So probably not that far. Wait till it comes around again. And we'll just use this switch here, basically. These are pretty close right here. Now that's pretty close right there. However, it's not at the point where it would start yet. So let's move it a little bit more. Let's try it right. So these are pretty close right here. We want it to the point where it's going to start pushing this away, right? So once it starts getting down and starts pushing it. So I think a little bit more, a little straighter. That might be too much actually, because if I try to push this down now, it's going to probably, yep. All right, I'm getting an idea where it should be. I think almost kind of straight out. I'm gonna think it. I'm gonna kill the power here. All right, let's try right here, see what we get. This is pretty close, I think. So we're gonna put our little, hold on. This rides in this sleeve right here, and then this attaches to here. Why is that not going down here? Da, da, da. Like that. Okay. And our nut. So we're using a lock nut here so that that doesn't come loose, and we can tighten it just enough so that it's on there but not tight so that it can slide. Obviously, we want it to be able to move. All right, let's try it right here. Turn the power on. Get my trigger wires here. Let's see how long it takes. One. So it's like, that's kind of like, still takes a couple seconds. Yeah. Let's see. 1, 2, 3, 4, 5. It's like 5, 6 seconds before it'll go. So we probably want to, yeah, try to get it closer. Which means we need to be farther down so it's almost ready to start pushing, right? So I'm thinking, because this is the stopping point, right? I think we want to be down here somewhere pretty much. So let me play with it and we'll come back and I'll show you the final operation. All right, so there it is. It's pretty much finished at this point, and now we got the motor on the other side here from where I originally had it. And this will mount into the tread section here. That's what these two brackets are here for. These two brackets right here basically will kind of go like this. These will mount where two of the wheels come through the sides of the tread. So I'll show you that when we get to that point. And then this will here, and you can see it, everything is slotted so things can move around and be adjusted. This is just aluminum, simple bent aluminum here. And that's pretty much it. So yeah, so when it's connected to the computers and everything, there'll be a sequence where, you know, whether it's voice command or a button or whatever, and it will then trigger, you know, a relay to hold this down for a certain amount of seconds. And then once it starts its sequence, it'll continue through. So it'll come out the door, drill a hole in the ground to get its sample, and then it'll go back into the tread section. And that's pretty much how it'll work. Now, this will obviously require that it be aligned correctly, because basically what happens is this pushes the little door open on the front there, and it just sort of comes out, and then the door closes behind it. So this has to be, you know, at the right height, it has to be at the right angle and everything else. So this is where it gets sort of like just time consuming getting this mounted. But this is a big deal here to have constructed this piece and have it available, right? And then be able to mount it into the tread section. So as soon as we get this in its correct mounting position and everything, then you know, we're ready to really kind of button up the treads as far as like we've got everything drilled, we know everything's going to be bolted on, so we just have to take it all apart and then paint everything and then get it all back together and then see if it's all functional. So we do have a couple other little things. We've got some wiring and power things to do yet, but we're moving along here on the tread section. So next, get this mounted inside there. Got the soil sampler mounted in here, just basic mounting. Everything is lining up pretty good. So what we're going to do is we're going to test it real quick. So here's the front with the door, and I'm going to just trigger it here to get it started. And we'll take a look. And there it goes through its cycle. And that's supposed to, you know, be picking a soil sampler. and then it goes back. Now, there is one little adjustment I have to make, so you can see the door is not quite closing. And the reason is because if you look right here, you can see that it's not going quite back against the aluminum plate here. This should be back a little bit further like that. And the reason is because, and then if you look on the front, you see the door is closed now. So that's because of the micro switch on the other side. So it's hitting it a little bit too soon. It needs to be just a little bit more. So if I give it a little like energy, you can see it'll kind of settle in, right? Puts it right against it right there. So that's where it should be when it ends, but it's ending prematurely because it's hitting the micro switch, which just needs to be adjusted a little bit. And then what will happen is the door here, as you can see, will be completely closed. So a little adjustment there, but that's not a big deal. We'll have to pull this out. It's only these. They're only hand tightened right now for these nuts right here. So we'll have to pull that out and adjust it and then put it back in. So not an easy thing to do to get it all in here. You can see it's a very tight squeeze, but we did manage to do it. So once we get that done, then the only thing we have to do is the caster wheel on the front here, get that mounted up, which will be next. And then I think most everything except for the wiring for the power is finished, and we'd be ready for final paint and texture and then final assembly. So we're getting close, but yeah, let me get this adjusted, and then we'll also get the casters finished here, and that'll be the I think that'll do it for the first episode on the tread section. The next step is to get these casters on the front mounted. So what we've done here is we've created this bracket out of steel. It's just a mending plate and 2 angle brackets, and we've drilled holes, and you can see right here it fits right in here perfectly. Okay, so what we're going to do is we're going to mount it using the 2 holes here that come through for this is the axle that comes through for one of the wheels, and we're going to use this as one of the holes. And what we're going to do is, because we know about where it needs to be, but I want a final adjustment where I can move this up and down a little bit. So what we're going to do is we're going to drill a hole that's about 3 times bigger than the axle or the bolt coming through there, so we can move it up and down a little. And then once we get it into our final position with the height that we want, we will tighten it really tight, and then we'll put another screw right down here as the stabilizing bolt, and then it can't move out of position. But we want to have that slack first. And so what's going to happen is we got to get the caster mounted on here first. You can see I've got some markings there for the holes I have to drill yet, so 4 more holes. We have got to create one of these for each side, and then once we get the caster mounted on here, what we're going to do is we're going to get these mounted in here and put the 2 halves together. So we got to put the 2 halves together again, and then check the level and make sure everything is exactly where we want it before we then put the final stabilizing bolt in there. So it's a process. We're constantly putting things together, taking it apart to get everything lined up. But this is great. This is solid steel. It's not going to flex, and this will work really well in here. And then, like I said, we'll be able to adjust it. So I got to get the caster mounted on here yet, 4 holes. And then we've got to get the holes drilled on the side here for the main bolt that's coming through, and then the final hole won't be till the end, till we find our final position. So let me get all this done and we'll come back. Guys, so we have everything bolted on now. We've got the 2 front casters on. I'll show you the brackets there in a second, how we made them. But basically, I've got it on the floor, 2 halves bolted together. So here goes our big test. So first we're gonna go across the front here, and we're gonna zoom in on this bubble. And let's see, hold on, zoom. And that is like near perfect, right? That is almost perfect. I think if I raise this side just like 2 hairs. It goes, but that's close enough. I mean, that is so close. All right, so that way it's level. So let's go this way. Okay, and if we go this way too, and we go over here, and same thing, we're gonna zoom in on that bubble. It is near perfect. I think the, let's see, the front, yeah, it's just a hair low there, but, and then we could actually bring that up. But if I wiggle this, right, it's flat on the ground, and it moves, right, pretty easily. Right now the wheels are not, you know, they're locked, so it's not going to move, but that's pretty good as far as the treads go, and brackets and everything else. So that is a big deal. We've got the soil sampler in here, we've got the front casters on, we've got the motors in, and the only thing we have to do at this point is put a screw in, or another bolt, to fix the plate in place for the casters. So let me show you that. What we did here is on this side where there's no soil sampler, this was pretty easy, right? So we have 2 brackets, L brackets, and a plate going across. We just bolted 4 bolts to hold the plates onto the brackets, and then the brackets have a hole in them that go with the bolt that comes through the wheel on each side. And then I slotted it so that I could adjust this up and down. So I measured about what I thought was the right distance between the bottom of the bracket and the bottom of the tread section here. And that's pretty darn close to level. So we're gonna leave it exactly where it is. So so we're gonna mark this around. But what we're gonna do is, we left a spot here. The way we line this is, we made sure that this hole was not centered in the bracket. It was a little farther up, so that we could put another hole right here, and put a bolt between the wheels here, so that I could fixate this so it doesn't twist. In other words, so it doesn't go this way or that way, because we only have the 1 bolt holding it in. So we're gonna do that on both sides. So 2 holes drilled here and then 2 on the other side. That will fix this in place, because we do have to take these wheels off, which again, I'll talk about the wheels later, but we have to take these off to do our final painting and everything, because we don't want them all over these aluminum wheels here. Now, on the soil sampler side, it was a little more complicated, because the sampler is right here on top of this. So first of all, the bolts I had to put in the opposite direction here for the caster, so that the head is just on the other side, because there's a space I have to worry about. I can't have it banging and crazy. And then what I did is, because there's a bolt coming through that mounts the soil sampler, that's the bolt I use to also sandwich this in between. And then I have some washers in between there that basically pull it down far enough so that everything clears between the two. And that's pretty much it. And then the soil sampler has 2 other bolts down here for its brackets, which aren't included in that. So same thing here with 2 holes that we'll put through to fix these plates in place. And that way, the soil sampler will stay in place, this will stay in place, and it really won't move. We're just gonna take these bolts out to take the wheels off, and then this won't move out of place, since everything's already aligned exactly where I kind of want it. And that, you know, that's how I did the front caster, so that it can pivot and turn left and right and everything. So really happy with it so far. So everything is, all the major work here is pretty much done with all this drilling through steel and everything. So we've got to get these final bolts put in, and then what we'll do is, let's see what else we got. Oh, we do have to put the tread belts on here and get them tightened up, and just verify that once they're inset in the wheels here, they don't stick too far down and they're not rubbing against the ground, and I have enough clearance on the bottom. But other than that, we'd be ready to go. There is a switch here in this hole that you see right there on the bottom. I have to make sure that fits in there before we paint, just in case I have to make it a little bigger or something, right? So we don't want to break up the paint. And then I think we're ready to take all these wheels off
and then get it ready for paint. Prep it. It gets a texture, and then it gets final coats of paint. Then it'll have to sit for a couple weeks while the paint really hardens before we start reassembling all this. But the big work here is sort of finished now for all the structural stuff on the tread sections. Then we'll start building up from there. All right, guys, well, I hope you enjoyed that video, part 1 of our episode on our tread section. We got a lot of build done. Pretty much all the structural build is finished here. And our next step is going to be texturing and painting. And then on the next episode, final assembly, hopefully, of everything up to this point on the tread section. So we still have some work to do to finish this out. But yeah, big progress here on the tread section. Got the motors in, soil sampler, everything is level and perfect, so this is going to be really cool when you see it running around. So, but anyway, as always, make sure you put your comments down below about this video. Make sure you subscribe, hit that like button, and I will see you on the next video. Peace, guys.